Alright, welcome back everybody. This is Spoopy909 and this is Let's Code in C. Today we're going to be talking about casting. Now, if you remember correctly from the previous episodes when we were talking about variables, I made it clear that when assigning variables, that the left side type has to match up with the right side type. Now this is true. But let's say we have an integer and we want to put it into a double, or take a double and put it into an integer. Now we can do this with something called casting. What casting does is lets you change the type of your variable. But not all variables are created equally, so there are consequences to doing this. So we'll go over a few examples today of casting. I'll show you how it works. Let's start off with putting a integer into a double. We'll cast it to a double. So let's say we have a double called double1. We have an int called int1. And we'll give that a value of 10. Alright, so we have this int value of 10, but we want to put it into that double. So this is what we can do. You can say double1 is equal to. Now we need to cast the integer into a double. To do this, you open a parentheses, you type in the type that you want to cast your variable to, and then the variable name, semicolon. Okay? And what this says is it says, take this integer 1, cast it to a double, and store it into a double 1. Which is perfectly legal. So let's print this out just to demonstrate. Now notice before I never give value to double1. The only value it has is from this 10. Okay. So let's compile it. Oh, whoops. Forgot my dash. Alrighty. Let's run it. Now look here. See, it has 10.0000. Even though this was an integer type, okay, let's not cast it to a double. Let's just print out the integer. Okay, see, it's a 10. So that's pretty cool. We changed the integer into a double. Alright, so let's say you want to change a double into an integer. Well, you might notice there's a little bit of problem with that. The problem here is that a double has decimals at the end of it, where an integer does not. So what happens to the extra decimal places when you cast to a double? First intuition might think, oh, they'll just round up or round down, but that's not the case. When you're casting a double into an integer, the decimals just get knocked off or truncated. They do not get rounded or anything, they just get sliced off. We'll demonstrate that now. So let's say we get a value of 10.5. Now if we're rounding, this would be go to 11. Okay, we'll store an int1 using a cast, and when we declare the type here and then put the variable name, we call this explicit casting, because there's two different types of casting, explicit and implicit. We'll go over implicit in a few minutes. Let's just print this out to see what it's going to give us. Like I said earlier, the value will just get knocked off. It will not be rounded to 11. This should just print out 10, because it just gets knocked off the end. There we go. Have a value of 10. Okay, so that is one problem with casting, is that you have to be really careful, because doubles cannot go to integers. Integers can always go to doubles, because it'll just add in some extra zeros at the end, which is always good, or not good, legal. And the doubles, it's usually, unless you're doing something very specifically where you want to get rid of all the decimals, it's not a very good idea to cast it to an integer. Now I said something about implicit casting before. Implicit casting is when you don't even put that there. You just put it like that. Now with the newer compilers, they're smart enough to cast that to an int for you. But they might give you a warning saying, oh, do you really want to do that? Let's see if we get a warning. Nope, no warning. In some other languages, they might give you a warning, but here they didn't really give us a warning. C lets you get away with a lot of weird stuff without warning you, because C is a little bit lower level, so the compiler kind of assumes, oh, you're doing it on purpose. Other languages like Java and maybe even C++ might warn you that you're casting a double into an integer. But it's always good programming style to put the int there, so it's specifically to an integer. Okay. Now there's one other type of casting that I want to go over before we end the episode, and that is a character cast. Say we have a character A. Now, characters are really just integers. The way the compiler knows that this is A is because it's an integer that has what we call an ASCII value. And the ASCII value of lowercase a is 0041 or 42, something like that. And when it reads that integer inside of a char or a char, it knows that that's an ASCII value, okay? And it knows that since it's a char, then it needs to be A instead of 0040, whatever it is. So since these are really integers, the chars here are really integers, we can actually cast it and put it into an integer, which is kind of neat. Okay, and then this will give us the ASCII value of A. We'll print out int1. Let's see what it gives us. 97. I thought it was 40 something. I guess I was wrong. 97. Okay. So 97 is the ASCII value of lowercase a. So what's also really cool is that you can cast this to a character, an integer into a character. So what was it? 97 was lowercase a. So you can say 97, cast it to a char, and put it into a char data type. Now let's print out char1, and we should get A. And there we go. A. And there's lots of really cool tricks you could play with chars since they're really integers and really numbers. You can do a lot of cool stuff with it. So let's go over a little review. When you put the actual data type they want to cast into in front of the thing that you are casting, we call it explicit casting. When you delete this, that is called implicit casting, because the compiler will cast it for you. Alright, and that's it for casting. That's all there is to it. This is Shmoopy909. Thanks for listening.